Welcome to the second podcast of the Mr. Kropke's Geometry Extravaganza. Today we're going to be talking about the areas of triangles and parallelograms. We're going to do something a little bit different today, and the first podcast is going to be nothing except for taking down the notes of the two formulas, and then the second podcast is going to be the sample problems pertaining to these figures. So the first figure we're going to talk about is the triangle. As we know, a triangle is a figure that has three sides. We have had different types of triangles. We've had acute triangles, we've had obtuse, and we've had right triangles. No matter what, the formula that we're going to use is going to be one of two variations. I personally will use the first one, and that is b times h over 2, or some people prefer the 1/2 b times h. Which one you use depends on your preference. But again, I will use the first variation. Now, B is always going to stand for the side of a triangle. Any side of the triangle can be considered the base. The H is considered the height, or what they refer to as the altitude to that base. So what you should be looking for is a segment perpendicular to one of your sides. So let's take a look at some of the types of triangles that we're going to have and where that height may appear. The first type of triangle is the acute triangle. So what I'm saying is this bottom side of the triangle is going to be considered my base, and then this dotted line, which doesn't really exist, but it's there to show me what my height would be or what my altitude would be. Again, the right angle right there determines that it is an altitude. So if I was going to find the area of this triangle, this would be considered my base. This would be considered my height. And then I would just do base times height and then divide it by 2. Now, I would not write down what I'm going to do next. You can use the other sides to be your base as well. It is possible that this could be considered your base. But then the altitude would have to come in looking like that there. So again, this side could be my base, but then the altitude could be drawn in, but it has to come from this vertex down and perpendicular to this side here. You could also have the other side to be your base as well. You can use this as your base, but then again, your height would have to come down right there. So any side could be your base, and then the height is going to be that segment perpendicular to it. Now, when you have a right triangle, you're kind of limited in terms of your height and base. What I always say is the two sides that form the right angle would be considered your base and height. It doesn't matter what order they go in. So again, when you have a right triangle, your base and height are going to form the right angle. It does not mean that your hypotenuse cannot be the base, but in most cases, the right side, the two sides that form the right angle will be your base and the height. Now, the one tricky part is when you have an obtuse triangle. If this is the triangle I'm trying to find the area to, a lot of times what they're going to do is they're going to drop a dotted line out, and then they're going to show a dotted line out to that line as well. Don't get confused. When you're trying to find the area to this triangle right here, the base that you want has to be a side of the triangle. So from here to there would be considered your base, and then your height is this dotted line outside of the triangle. Okay, they will probably give you this number here, but don't use it. It's not part of the equation. The other thing that you need to keep in mind when you're doing the problems is that when you have an equilateral or you have an isosceles triangle, when you drop the altitude down, you're going to bisect the base. And again, this is for an isosceles triangle and when it's an equilateral triangle. Okay, also when it's equilateral, make sure you remember that all the angles are 60 degrees. The next figure we're going to be dealing with is the parallelogram. And the parallelogram is just going to be a nice clean-cut formula, which is b times h. And again, the b is going to stand for the side of a parallelogram, and then the h is a segment perpendicular to that side. Remember in a parallelogram that opposite sides are congruent, and again, either side could be considered the base. So if I'm going to use this piece right here as the base, okay, this is not going to be the height. What you're going to need is a segment perpendicular to that side. So if this is going to be my base, then the height would be this segment straight down from the top corner. And then it is also possible that this could be considered your base as well. So you could consider this your base, but if that's the case, then what you're going to need is a segment perpendicular to it, like such, and then that would be considered your height. So at this time, what I would like you to do is go to the samples. I want you to try them on your own, and then turn on the other podcast, and that would explain how to do each and every one of those problems. Again, if you have any problems, make sure you stop in the morning. I will be there bright and early. All right, thank you.